So I'm Matt Baldwin. I'm the Director of Cloud Native Engineering here at NetApp, and I'm here today to talk to you about NetApp's Cloud Data Services strategy and how we're trying to simplify enterprise multi-cloud deployments of cloud-native infrastructure and cloud-native workload. We build this on top of 6 different pillars that we've defined in our product, which is the first is, how do we simplify enterprise multi-cloud Kubernetes? And what we mean by that is, what we're trying to arrive at is that you do not have to worry about the cloud provider that you're building your cluster on top of, that you're managing your infrastructure on top of, that the experience matches the same. So if you're using Google, that experience is the same as Amazon, as is the same for on-premise, and that's what we're trying to do with our enterprise multi-cloud Kubernetes offering. Our second pillar is application management, and we're trying to follow the same theme there, which is to, how do you simplify the developer experience with building, shipping, and running applications inside of Kubernetes? How do you ensure those applications can scale? How do you automate that? How do you scale them across multiple providers? How do you scale them from on-prem to off-prem in a hybrid scenario? And that is what we're driving at with application management. Essentially, how do you transform a Kubernetes cluster into a Heroku-like experience for the developer, so they never have to understand Kubernetes, they don't need to know what Istio is, they can perform a canary, not a problem. The third component that we stand on top of is managed data services and storage. So NetApp is a storage company, as many people know. And we have over 20 years of experience in enterprise-grade storage and delivering solutions out to consumers and to customers. And what we're doing is we're working to lift all of those features into and pull those into Kubernetes so that we can guarantee your application, we can protect it, we can guarantee IOPS for your app, we can move your app around from provider to provider and the storage will follow you. Snapshot, mirror, clone, all that goodness comes from the NetApp technology that we're pulling up into Kubernetes. And that's one of the primary pillars that we're standing on top of, is that we were able to, we've solved the stateful workload problem in Kubernetes at NetApp. And that's very important, as you guys probably all know, for Kubernetes. The fourth pillar is ecosystem integration. And what we mean there is we don't mean just taking Helm charts and throwing them into a bucket of a marketplace and then letting the user figure out what they need to do with that. When we're talking ecosystem integration, we're talking about deeply integrating with ecosystem partners to deliver a value out to their users versus being a feature farm where you're trying to just iterate through as many features as possible. What we're trying to do is arrive at user value. So when that user clicks that button, slides that slider, enables that feature, that they immediately have value that they can consume. And we have a partner that we're going to bring on stage here in a bit to talk about that type of ecosystem integration. The fifth item is, again, we're trying to build simple tooling for developers, operators, and SREs. As our SRE teams figure out and solve issues, we're pushing those feature sets, those types of dashboards down to the end user so those users can use those things. The sixth pillar for us is channel partners. So our product actually enables you to rebrand. So anyone can launch their own Kubernetes service. We can partner with anyone. We have a partner we're bringing on stage, again, who will show you one of the partnerships that we're doing on that. But it allows us to enable our enterprise partners to sell to their enterprises and enable that through the channel. So we not only go direct, we also go through the channel, and that's one of the big pillars that we stand on top of. So why are we here today? So we have 4 things that we're going to announce. First, that we're working with NVIDIA. NVIDIA and NetApp are working together to deliver an NVIDIA Kubernetes Services product that focuses on deep learning, AI, ML, and I have Adil El-Halik will be coming on stage to talk about that. The second item is our cloud-native application management is going to go to pre-release, and that's going to be a bulk of this presentation. We're going to show you what that is, and I'm going to have Dan Norris, one of my senior engineers, will come on stage to demo that and take you through all that work. And again, our focus has always been to simplify the experience for the user, and I think that's going to come through when you start to see the tooling that we've built for developers. The third item is we've enabled what we call an NKS enterprise registry, which is built on top of, we've effectively integrated into the CNCF Harbor project to enable enterprise registry in public cloud and private cloud as well, and that's all wrapped up inside of our workflow. The fourth item is cloud volume services on GCP, and that we're going to be going into beta with that at the end of May, and because storage is rather important to applications. And so we're going to conclude today's presentation with a discussion around cloud-native persistent storage and how that relates to what we're doing. And I have Aleem coming on to do that. So first, I want to bring up Adil, who will talk about our NVIDIA partnership on Kubernetes.
Thanks, Matt. Good morning, everyone. My name is Adil Halak. I'm Director of Product Management over at NVIDIA. I look after NGC. So real quick, what is NGC? NGC is an accelerated software hub, some of the most popular accelerated applications out there in the marketplace. We start off with HPC and visualization, but naturally that bleeds over into ML and DL, which is a huge focus of ours. So start off as a container registry, but we've expanded it to a lot more than that since. We've since introduced pre-trained models that are domain-specific across medical imaging or video analytics. Also some models that are up there just ready for inference. We've also introduced model training scripts, so teaching entities how to train to state-of-the-art accuracy and get models how to converge state-of-the-art accuracy from scratch, right? So tell you exactly what container to pull, where to get your data sets, what learning rate to set, and be able to replicate some of those accuracies that we drive. And again, growing above and beyond that, where we really start deriving value is when you become domain-specific, right, industry-specific. So as Matt alluded to earlier, we are introducing industry-specific Helm charts or workflows that frankly go from an end-to-end perspective. But why are we here, right? We realized that that wasn't enough, right? And I love this theme that Matt's been driving, which is the simplification theme, right? This is a software hub. If it's almost giblets. The reality is data science is a team sport, right? And often we talk about the data scientists, we talk about the developers, but it takes an array of different personas collaborating together to realize and derive value, right? We didn't even talk about DevOps, systems admin, IT managers who have to worry about auto-scaling, who have to worry about OSs that are supported in their data centers or in their respective clouds. So how do we alleviate some of those concerns? And this is why we're partnering with NVIDIA, with NetApp on the NKS service. So real quick, let me show you, if you don't mind going to the computer, please. Let me show you what NGC is all about. As I said earlier, containers across an array of different industries and segments. So you come to deep learning here. Our engineers, our data scientists, optimize against our GPU accelerations, optimize TensorFlow. We upstream those to the community, to the open source community as well, but we also post those on NGCS containers on a monthly basis. As I said earlier, we got pre-trained models across an array of a couple different industries and some that are already ready for inference, and these model scripts that I talked about. Again, really showing you how to reach state-of-the-art accuracy, get your models to converge, and be able to build on that. But as I said earlier, that's not enough, right? How do we go from use case to actually being able to deploy a prototype? And so what we're introducing, and what we're going to be showing later on at the booth on the demo, is, if you go back to the slides, please, is the ability to deploy a container or a Helm chart directly through the NGC portal, through the NetApp Kubernetes service, right? So as a data scientist or an ML, doesn't matter what your proficiency level is, right, to be able to deploy with a few clicks onto your favorite cloud service provider, right, or on-prem seamlessly with just a few clicks. And we're just starting with inferencing. Inference is the first use case, and that's the one we're going to be demoing over at the booth at noon, right? Again, with just a few clicks to be able to deploy on a Kubernetes-based cluster, auto-scale up and down, and as many nodes as possible, our inference server, right, which can concurrently run multiple models on a single GPU or on a single node. And we're starting with inferencing because we think that that derives value, right? This whole notion is about simplifying so you guys can derive value. But we want to get your feedback. We want to co-create with you guys, right, in this audience. Tell us, is it deep learning training workflows that you want us to focus on? Is it something specific to machine learning and our rapids libraries? So we're super excited. This is just the start of what we're kicking off. And again, we want to co-create with the audiences. We want to derive value as opposed to just providing shelves of software. So we look forward to hearing from you guys as we go along in terms of what are some of the use cases you want to see, but more importantly, we hope to see at our booth later on at noon, where we're going to be executing an end-to-end demo on this. So without further ado, let me introduce Dan. Sorry, we have 5 speakers. I wasn't sure who the next one is. Let me introduce Dan real quick onto stage, who's going to talk about app management. Thanks, Dan.
No, no problem. Turns out I don't actually need that. Hey, everybody. So I'm pretty excited to share with you what we've been working on to kind of improve the foundation that we've had with NKS. So what we have been pretty good at is delivering Kubernetes, like a consistent experience across multiple clouds. And what we've been working on, me and my team, is basically a suite of features that we think of as application management. So our goal here is to give you Kubernetes clusters that are batteries included, so to make the developer experience best in breed of any product out there. So what we've been focusing on are things like providing a Git-based workflow, so basically doing a Git push sort of workflow to be able to actually create Kubernetes deployments automatically, to be able to detect what type of application you're actually delivering. And we've also been looking at shipping application health dashboards, metrics, logging, pretty much everything that you would want as an SRE while actually going through and delivering value for your product. And we're not really standing in the way here, right? These are all sort of opt-in additions. We're implementing them as Kubernetes custom resources. So these are things that we're pre-installing on your cluster, ready to go whenever you spin up a Kubernetes cluster on NKS. And so things that we're adding on here too, quick auto-scaling, resource management, quota configuration. And we've got a number of different solution types, and I'll walk through sort of what that looks like as we get a little bit into the demo. So what you're going to see is sort of our take on what we think application management should look like. So the way that we think of it is that applications, we deploy them into projects. If you're familiar with Kubernetes terminology, a project is basically an abstraction around Kubernetes namespaces. We add a little bit of magic on top of it, again, through using custom resources. And then what we call solutions are basically definitions of how you deploy your application. It's not just a deployment, a stateful set, a daemon set, right? This adds context. This adds value by showing how you actually deliver your application, how it gets to your cluster. So a little bit more about projects. We think of it as a container, right? You want to take everything that comprises your application. So perfect example is, say, WordPress, right? You're going to need MySQL server. You're going to need the WordPress PHP, and all the other pages that go to that. That belongs all in the same project. Those might be multiple pods. You can scale them differently. Doesn't really matter because it's still all Kubernetes at the end of the day. What we add on top of that is, again, extensions to namespace. So we hook into, through our product, RBAC. So we effectively reflect that into the clusters so that you as a cluster admin can take that and restrict who has access to these particular resources. So say your SRE team is allowed to make changes to your production applications, but your developers are only allowed to read them, right? That's what we've kind of added on as an extension there. And so in terms of the solutions that we've come up with, we kind of targeted 3 for our pre-release. So we have what we call the tracker, and the tracker is kind of like the lowest common denominator of our solution. It's basically you're an experienced Kubernetes developer, you're experienced at actually delivering applications on top of the platform. This is how you effectively inform our back end of what that is. So we can effectively adopt your application as is to keep your deploy strategy, and it just works. Again, if you're familiar with Kubernetes terminology, this is effectively just label selectors. We use that to kind of adopt an existing deployment and adopt an existing stateful set, and that way you can just manage it through our interface. And then the next solution that we have is the Git workflow. So effectively, Git push NKS master. We want to be able to take pretty much any application that you have in any programming language and make it that simple to deploy and get a Kubernetes deployment out of it. And the third that we've got are Helm charts, right? CNCF, going pretty hard on actually having Helm charts be sort of the package management solution for Kubernetes. So we want to support that. So all we really need to know is where does your chart live, and what changes do you want to make to its values.yaml, which is how you configure it. And we effectively take care of the rest. We deploy it, we manage the lifecycle, and we do this actually, again, if you're kind of familiar with the way that Helm kind of works, it's a client-server application. So we do it without the server component. Because we've written custom code and extensions on top of your Kubernetes cluster, we're able to actually lock that down and giving you a much more secure way to actually deliver Helm charts. And so now for the demo, we're going to do this live, so we'll see how this goes. Apologize. And where is... There we go. So let me just get to screen. So bouncing around, sorry. So what we have is basically a multi-cloud solution for deploying Kubernetes clusters. So what I have here, I have 2 different clusters that are deployed on GCP, all with random names, by the way. I didn't make any of these up. So Spring Mouse and Young Forest. The former is a 3-node cluster. The latter is a 7-node cluster, all in US West 1. We've got an AWS cluster, and we've got an Azure cluster as well. And so in each of these clusters, we pre-configure a enterprise registry. So this registry, because it's based on Harbor, allows us to manage both Docker images for your projects and also Helm charts. So we'll go to Young Forest and see what's on here. And so I've went ahead and pushed a number of images here. We've got Alpine, we've got Cassandra, we've got Ubuntu, and then we've got a couple Helm charts. And we can go through and we can see and subdivide by class, right? So we've got a couple of charts here, Envoy and Prometheus. We provide a registry token that we use for authentication. And to show that this actually works, we're going to retag next latest, if I could type. So this is just the upstream Nginx image. I'm just going to push it straight to the cluster. And here we go. So this is just pushing the image straight up to the cluster. It should show up as soon as this is done. Thank you, Conference Wi-Fi, for cooperating. We have to refresh the page. I'm impatient, sorry. So, not sure why it didn't pop up. OK, welcome to the joy of doing live demos. So that's our enterprise registry offering. And so the other concept I wanted to introduce you to is the project concept. So projects, effectively, you have n number of clusters. Clusters have n number of projects. Your projects are where your applications live. So we have a number of different projects sort of deployed on here. And if I expand them, this is an example of one. Actually, I'll do the one on GCP. This is an example of one that's running on one of our GCP clusters. It tells you the cluster where it's running. We can download the kube config straight here. And so in this case, we've got a relatively simple app and a couple other of ancillary solutions that are running. So we've got a Go backend supported by Node.js frontend, all running effectively on our Git solution. You can tell that because of the branch names that happen to be in the solutions here, in the service names. And then we've got an OpenEPS package, which is actually an install from a Helm chart that we've pre-configured. So now I'll walk you through what adding a project looks like. So I'll click on this Add Project. And because I'm super clever, we're going to call this Google Next Demo. And we will put it on this Young Forest cluster in the default workspace. So if you're familiar with namespace quotas, this is effectively what this is exposing right now. So you, as a SRE managing this or a cluster admin, can actually set quotas on the amount of resources that you use per project. So that way, any container or any application deployed into any of these projects can be restricted by how much CPU and memory that it uses. So you don't end up having one project taking over your entire cluster. So I'm not going to send any of that. I'm just going to hit Next. And then you have the ability to configure different teams, roles, permissions. I'm going to use the default here. So that brings us to kind of the project overview screen, where we are able to actually deploy solutions now. So I'll walk you through sort of what that ends up looking like. So I'll start off with, we've got, again, the 3 different solution types available. We've got our Helm charts on the left. We've got our applications or Git push workflow in the middle, and then our tracker, which is sort of the adopt your existing workload functionality. So I'll start off with the Git workflow here. And we will call this hello next. We define an update strategy because this is largely going to be a Kubernetes deployment, so that gives us the ability to go through and determine kind of how we want this to roll out when we do updates. We can auto-scale. I'm not going to do that because it's a pretty simple app. So that will create our application. Where'd that go? What is this doing? There we go. Cool. So don't know what that was about. Anyway, so because we're doing a Git workflow here, we actually pre-install a Git server. So any updates that go to that Git server will actually, we'll get an event and we'll be able to spin up a container and do a whole build process for that. So I have over here a fairly basic but kind of hype application. It is a Node.js application that's actually using Rust and WebAssembly in the back end. So I'm going to go ahead and add a new remote, which will let me push up to my cluster. Do that, and then I will go push this to the master branch in this Git repository. And so what we've seen is that this actually has pushed up updates to this Git server. And what it has done is it's actually triggered a pipeline. So we pre-install Tekton CD pipelines, which is an open source project that's basically providing workflow abstractions on top of Kubernetes. So what this has done is actually triggered a build of creating the Docker container, creating the deployment, and doing the whole build process, managing all that for you. So to see that in action, we can see that we have one pod that's spun up, and it has a couple of init containers because that's how Tekton CD pipelines work. So this is going ahead and it's actually building the container, it's pushing it to the registry, and then it's going to create a deployment. So while that's doing that, I'm going to show you what installing a Helm solution looks like. So I'll go back to our main screen, I'll add solution, I'll add a new package. And one of the things that we provide here is a set of pre-baked, effectively, Helm charts that we've gone through, we've vetted, that we know end up working on our system. So I'll just install Redis. You have the ability within the system, so I'll rename it to Redis. You have the ability to actually go through and edit the values.yaml here. So in case you wanted to customize the deploy, you can do that straight in the browser before you actually deploy the application. So I'm just going to go ahead and create it. And what you get is the package information that comes straight from the Helm chart. So that's all basically part of the package that is uploaded wherever it happens to be. And going back to our terminal, you can see what this has done is it's actually created a Redis slave and a Redis master. So we have kind of a highly available solution here. And so that's just sort of creating in the background, kind of just in the deploy process. So the third solution type that we have, if we go back to add solution, is our tracker. So tracker is pretty simple. Call this track app. All you do is just give this a series of key value pairs to go ahead and track your deployment or your application. So for example, you can do app equal, I don't know, test app. Why? OK, I don't know what that is about. Anyway, so that's pretty much you get the point out of that one. Cool. So going back to our terminal, kind of as one does with anything Kubernetes related, this is actually going ahead and creating, it has moved on, so it has created the Redis application, and now it's running the Node.js application. So to show that in action, because I'm not sure if I want to wait for it to finish doing its thing. Show you what this looks like when it's deployed. Let's go out to ye olde internet. So one of the things we do here is we actually use Let's Encrypt to give you a fully encrypted end-to-end connection to your application. So this is just the demo app. It's just Rust and WebAssembly and Echo. All it kind of does is kind of type in a sentence in a language, and it tells you what it is. So That's pretty much all of the workflow features that we've been kind of working on. And so pretty excited for everybody to start trying this in pre-release. So with that, I'm going to turn it over to Aleem to go talk about sort of all of our data solutions that powers all of this. Thank you. Here we go. Yeah.
Hi, good morning, everyone. My name is Aleem Karim. I'm a product manager at NetApp. I'm a product manager for our Cloud Volume Service offering. So while Matt and the rest of the Kubernetes team have been busy at work, basically deploying all of the cloud-native application tools that you mentioned, we've also been hard at work, basically building out a cloud-native file services offering that's high performance in partnership with GCP. That service is called Cloud Volume Service. And really, I'm going to talk about the why first, why we did this. What we heard from customers really were two things. One was that they had existing file-based applications and workloads that they wanted to move to Google Cloud. So they needed POSIX-compliant file services in Google Cloud, but not only that, they needed those services to be highly performant and highly available. The second thing we also heard was for cloud-native applications, being able to have storage services that were very flexible, easy to manage, and performant for all of the stuff that they were doing for persistent applications in Kubernetes was another gap. So with Cloud Volume Service, those are really the two use cases that we're going after solving for customers. So that's a little bit about the why. So let's talk about the what. What is Cloud Volume Service? So as I mentioned, it's a fully managed cloud-native file services offering that we've built in partnership with Google Cloud. And when I say it's fully managed, what does that mean? It means that you as an application owner or as a developer simply go into the Google Cloud Console or with our beta release using the APIs, provision an NFS endpoint that has capacity and performance characteristics. You don't have to worry about any of the back-end infrastructure details to actually deliver that endpoint. So capacity planning, networks, security, all of that is really managed in the back-end by NetApp and Google. You simply, as an application owner or a developer, simply consume the endpoint with the performance and capacity that you need. To show the simplicity of this, actually, we're running a little short on time, so the demo is something we're going to do at the booth. But we're actually running a fun contest at our booth for people that have never seen a cloud volume, don't know what a cloud volume is, to go spin one up. And I think the current record is around 18 seconds. So in addition to being super simple to provision and super simple to consume, Cloud Volumes provides high availability within a particular Google region, and there's a set of regions that we're currently available in. But the next big thing is around performance. Cloud Volumes enables a set of workloads now to run in Google Cloud that was previously unable to run, ever. So we're able to provide hundreds of thousands of IOPS and guarantee those via SLOs at very, very low latency. So most of our regions we deploy the service in, sub 2 milliseconds you can get for over 100,000 IOPS. So again, this opens up a whole class of applications that were previously not able to run on GCP. Finally, I mentioned this notion of being built in partnership with Google and being basically a native service within GCP. What does this mean? It means that customers are able to log in through their familiar terms with the Cloud Console, go into the Cloud Console without any other identity or access management integration from NetApp, just use your standard project and the credentials that you use to log into your project, discover the Cloud Volumes UI or the API, enable it, and go and provision your volumes. That means that there's really no leaving the Cloud Console, so the whole experience is very, very seamless like any other Google native service. We also integrate with Google Service Control, for those of you that know that facility. It allows us to push all of our metrics, logs, and monitoring data into Google Service Control, and so you can consume that data from Stackdriver and essentially monitor what your file systems are doing in terms of performance availability, and then be able to even monitor and set alerts from Stackdriver natively like you would do for any other Google service. And then finally, from a support perspective, this is aimed at enterprise workloads, so support is actually provided directly by Google. Google may escalate some issues to NetApp in the back end, but by and large, you as a Google customer deal directly with Google, even though it's a NetApp service. So I could go on and on talking about the features and what it's doing, but what I really want to do is hear from someone that's using this. And for that, we've actually got Louis Verzi from Cardinal Health. They've been using the service for a while, so I'd like to have him come up and talk about their experience.
Hi, Lim. Hello, everyone. Just wanted to talk a little bit about, like Lim said, how we came about our decision to use NetApp Cloud Volume Service and how our experience has been so far. So we have been spending the last couple of years doing a lift and shift migration, bringing existing applications out of our data center and into the cloud. We've started with our non-prod workloads, dev, QA, and have since moved on to stage and prod systems. And about a year ago, we switched over to GCP for many technical and business reasons. We really found GCP was a better cloud platform for what we needed to provide to our application teams. But as we started moving these stage and production systems, we realized that we weren't able to, as we wanted to, kind of get away from network attached storage. A lot of the applications that we had out there, some of them are COTS, some of them are homegrown legacy applications. They're built on assuming that they had NAS for providing high available solutions. And so we started looking around for a solution that would give us the ability to provision quickly on demand, not have to sign a PO with another vendor, make commitments. And NetApp met all those things for us, right? So it's been really easy to provision that storage and get data out to our application teams.
Thanks, Louis. So could you maybe give us a few more examples of the types of applications that you're running, as well as sort of what the ramp journey looked like?
Sure. We started out obviously with lower environments. Our SAP platform required a place for them to do their deployments through the environments. We started with that. We started with some other low-risk applications. We've since moved on to production SAP. We've got our enterprise content management that's going to be going into Cloud Volumes in production here shortly. It's been in our performance environment for a little while. So we're going to have 20 plus terabytes of our enterprise content serving up through our e-commerce site and through our SAP environment that is going to be running off of NetApp. What was the last part?
The other thing I was going to say is sort of what has the journey been like in terms of using the service?
The journey has been very easy, right? So the upfront work is just getting the networking set up, which with the beta release, I think that's going to be even easier. But really the hardest part was spending 30 minutes on a call with the NetApp engineers to get our networking connected up. After that, it literally is seconds to set up a volume. We always start with their standard tier. And if application teams aren't getting the performance that they need, with a click of a button, they can have twice the IOPS. With another click of the button, they can have 4 times the IOPS. If they need to grow from 2 terabytes to 5 terabytes, it's another click of a button. No restarts, no copying of storage, no expanding arrays, none of that complex work that system administrators have had to deal with in the past. So it's really a very easy solution that we can put in the hands of our application teams.
So one of the things in terms of outcomes, right, when you take these applications and move them to cloud, what kind of a time-based acceleration impact do you think having this service has made in terms of executing those projects?
Sure. If we had to refactor these applications out of using network attached storage, it would have taken months or years or longer, really. It would have taken months per application to get these refactored. And at Cardinal, we've got hundreds of applications that are relying on NAS storage. So it really saved us years of effort of having to refactor these applications. And it's something that application teams can kind of do on their own time now, where they can work on getting their storage into other formats that typically in a data center you don't have access to.
So you already pointed out one of the things that you don't like, which was the networking stuff that we had to do. And with cloud, it's amazing how much networking stuff you have to do. But what are some of the other things that you're basically looking for enhancements around that we're releasing in the upcoming release?
Sure, from being in a heavily compliance regulated marketplace or industry, a lot of our workloads are going to need NFS v4 with encryption. Obviously, you don't want to have PHI data anywhere that's unencrypted. They're already doing the encryption at rest, but we're looking forward to being able to do encryption in transit as well. The other thing is DR that we don't have to think about. Right now, we're using some services to sync our data to another region. It would be great if you could just, with a click of a button, have that replication taken care of, and then we wouldn't need to administer that. And the third thing is access across VPCs. So right now, with the networking setup that we have, we aren't able to access data across our VPCs. But there should be some solutions coming forward that'll solve that problem for us.
Well, thank you very much, Louis. So with that, I want to spend a few minutes talking about what is coming next. Many of the things that Louis mentioned has been feedback that we've gotten from Cardinal Health as well as other customers. So with the beta release that we're planning for the end of May, essentially we're going to automate the whole networking flow that Louis talked about, give users a lot more control in terms of which VPCs, which shared VPCs have access to the service, and how they govern permissions within their organizations and their service projects to get access to these data services. So if you've got service projects, GKE clusters that are in those service projects, you can actually have much more granular connectivity into these data services. We're also going to be rolling out Trident, which is an existing plugin that we have that will automate the creation of persistent volumes and persistent volume claims. When you're running stateful applications, that will automatically provision cloud volumes in the back end and connect those to your Kubernetes environments. And obviously, we're going to be adding more regions here in the US, in Europe as well. So before we get into sort of the questions, just wanted to sort of give the audience, please join our pre-release programs. A lot of these are driven by obviously conversations and feedback that we get from customers, but joining these pre-release programs allows you to provide feedback and really shape how we do these products. Engage with us on Twitter. Those are the names up there. Please visit us in the booth as well. We've got most of these demos and a bunch of subject matter experts there that can walk you through the stuff we talked about. As was mentioned earlier, the NVIDIA demo is coming up at noon. Is that right? Around noon. So that'll be another cool one to see. So that's about all the content we had. We wanted to leave a little bit of time at the end for Q&A as well, and I'll bring Matt and the rest of the speakers up for questions.